An AI model that trains continuously. Executive summary. Continuous learning allows AI models to update their knowledge using a constant stream of new data. Traditional AI models are static and become outdated quickly. Continuous models use techniques like replay buffers and regularization to avoid catastrophic forgetting, where new information erases old skills. This technology makes AI more accurate, efficient, and sustainable. It is essential for self-driving cars, medicine, and cybersecurity. Future AI will learn incrementally, mimicking the adaptability of the human brain. Article in the world of technology, experts often describe artificial intelligence as a digital brain. Most AI models work like a student who studies one massive textbook and then takes a final exam. After the exam, the student never reads another book. This static model stays frozen in time. It only knows what was in that one textbook. If the world changes, the model becomes outdated. However, scientists are now building a different kind of AI. This new model trains continuously. It learns like a person who goes to school every single day for their entire life. The problem with static AI. Static AI models face a major problem called model drift. Data in the real world changes constantly. For example, people invent new slang words every year. A language model trained in 2020 might not understand a joke from 2025. This happens because the model's knowledge is fixed. To fix this, engineers usually have to start over. They collect a new, larger data set. Then they spend millions of dollars on electricity to retrain the model from scratch. This process is slow and very expensive. What is continuous learning? Continuous learning changes this cycle. It allows a model to process a steady stream of new information. The model updates itself in small steps. It does not need to see the original textbook again. Instead, it adjusts its internal connections based on fresh data. This makes the AI much more efficient. It stays relevant because it sees the world in real time. We call this online learning or lifelong learning. The challenge of catastrophic forgetting. Learning forever is not easy for a computer. AI models often suffer from catastrophic forgetting. This happens when new information overwrites old knowledge. Imagine you learned how to ride a bicycle. Then you learned how to drive a car. In a catastrophic forgetting scenario, you would suddenly forget how to balance on two wheels. The new driving data would erase the bicycle data. This happens because AI models use mathematical weights to store information. When the model learns something new, it changes those weights. If it changes too many weights, the old skills disappear. Scientists use special tricks to stop this. One trick is elastic weight consolidation. This technique identifies which weights are important for old tasks. The model then makes those weights hard to change. It protects the old memories while allowing new ones to form. Techniques for continuous training. Engineers use several clever methods to keep models sharp. Each method solves a different part of the learning puzzle. 1. Replay buffers. A replay buffer acts like a small memory bank. The model saves a few examples from the past. When it learns new things, it also reviews these old examples. This rehearsal reminds the model of what it already knows. It keeps the past fresh in the model's mind. 2. Regularization. Regularization acts like a set of rules. It tells the model to keep its changes small. The model cannot completely rewrite its brain to fit one new piece of data. This keeps the model stable over long periods of time. 3. Progressive networks. Some models actually grow over time. When a new task appears, the AI adds a new layer of digital neurons. These new neurons handle the new information. The old neurons stay the same. This prevents any loss of original knowledge. However, these models can become very large and slow. real-world applications. Continuous training is already changing many industries. It is especially useful where things move fast. Self-driving cars. A car must learn to navigate different weather and road signs. Roads in a new city might look different. Continuous training lets the car adapt to new environments without forgetting how to stop at red lights. Fraud detection. Criminals constantly invent new ways to steal money. A static AI would miss these new tricks. A continuous model learns from every new transaction. It spots weird patterns immediately. Medical diagnosis. Doctors discover new diseases and treatments every month. A medical AI needs to stay updated with the latest research. Continuous training allows it to read new papers and improve its accuracy. Personal assistance. Your phone's AI learns your habits. It learns which music you like and how you talk. It adapts to your changing lifestyle over years of use. The future of lifelong learning. The goal of AI research is to reach artificial general intelligence. To get there, machines must learn like humans. Humans do not need to be re-downloaded every time they learn a fact. We integrate new ideas into our existing knowledge. Continuous training also helps the environment. Training a giant AI model takes a massive amount of energy. Continuous models only update what is necessary. They use less power than models that retrain from scratch. This makes AI more sustainable for the planet. Ethical considerations. Continuous learning does bring some risks. If a model learns from bad data, it might drift in a dangerous direction. For example, a chatbot might learn mean behavior from users. Engineers must build guardrails to stop this. They monitor the model's updates to ensure it stays helpful and safe. They also check for bias. If the model only learns from one group of people, it might stop working for everyone else. Conclusion. An AI model that trains continuously is like a living organism. It evolves and adapts to its surroundings. It overcomes the limits of static technology. By solving catastrophic forgetting, scientists are making AI smarter and more efficient. These models will eventually become partners in our daily lives. They will grow with us and help us solve the world's biggest problems.